Hello and welcome to my first ever YouTube video. My name is Andreas. I'm the creator of URSA Major Keycaps, and today I'd like to show you my process, my automated procedural process of getting these legends onto the keycaps for resin printing. I used this method during development of URSA Major, and I'd like to share that with you today. So let's get started. I'll start by showing you my whole graph, my procedural graph of how I have my keycap design set up, but this is for another video. Just quickly, this is a single profile, and these are the single caps, and we can iterate through them by the timeline. They're in reverse order to the industry standard numbering, but that's not concerning us today. So as you can see, we got the 3D data ready to be punched out by some legends. Okay, the legends are done in Affinity Designer. It's a vector-based program, and I've recreated the ApoMaker GX68 layout here. Added some color to get a feel for the key set, added some legends with the font. I think it's San Francisco, rounded, because rounded is a nice legend font, I think. And this gets exported into Houdini via EPS. But before we do that, I'm going to show you this text file. It's a comma separated value with 4 rows. The key ID, the key width, the row the key is on, and if the key is convex or concave. And it enumerates from the top to the bottom and corresponds to the layout here from left to right and then upwards. Let me show you how that works inside Houdini. Oh, we could export it. Let's export it. EPS, Houdini, don't export hidden layers because it's quite important. And then we're in the right directory and we save and replace. And now let's head back to Houdini. All right, inside Houdini, we grab the Illustrator EPS or the EPS file, and it's just as it is in Affinity Designer. It's just plain graphics or geometry inside of Houdini, but we need to associate this with our text file data. And to do that, we first separate the legends from their bounding box, which correspond to the footprint of the key. And we enumerate the rows and define an attribute for each row. So these rectangles have an attribute of R1, these of R2 and 3 and 4 and 5. And we also enumerate each of the rectangles just as I've shown you in Affinity Designer. So this is index 0. It's going from left to right and from up to down. So this is going to be index 0 and this is going to be index 67. And I'll save the reveal of this magic for some other video too. But we're combining these, and to verify that everything works, I'm going to show you that this node blasts everything except what I have set up here. So I'm going to template the background, and if I go through these items, I'm going to reach the last item, which will be enumerated as 67. All right. So that's quite nice, but how do we get them onto the keys? Well, this node here is not index driven as this one, but it's set up a group, and that group corresponds to a string, and the string is held in a node which I named multi-width, and the parameter I didn't really name. It's called new parameter 4. Okay, let's find that node. It's right here. I'm going to pop the properties for that node, and you can see if we look oops, where are we? If we look to this node, which actually references to this legend here, we can see that we got the A picked. And let's hit a 1, and we got the 1 and the Q and the A again and the Z, and let's do a command. All right, so we've got a string assigned to some graphics. This is really nice. And let's have a look of what this looks like on the actual keys. So back to the keys and getting rid of this template. Let's see, this is command, but that's not really nice of a command. This is much better of a command. Sorry. And we can see that we've booled out. Never mind. This doesn't look really nice because we've got some normals to fix and the key to rotate. Oops, not here, etc., etc. So that's command. Let's do this again, starting with 1. Oh, look at that. It's on R1. And the Q is on R2. And the A is R3. And the Z is R4. And the command is R5. I'd like to quickly show you how Houdini knows all of this. For that, I'm going to bring up the attributes view. And down here in the attributes view, you can see that the legend is carried over and the row is carried over. So, and please bear in mind the row is reversed. So if I hit 1, we're going to get the row name of 5 and the legend of 1. If we do this with Q, we're going to have legend Q and row of 4. And this is all there is to it. Okay, but you already guessed it. If I were to do this key by key, what would it save me? I would have to export this, wait, set the next key, export that, and wait. We can do better. We can do this in an automated way. But first, since this is for resin printing, I'll show you that there's that I got supports set up, and these supports are also procedural. They correspond to the key width, and keys that need more stems have more stems. And wait a minute, see control's only got 1, so that's fine. And the space bar, I'm not sure if that works. Does the space bar work? All right, so the space bar has lots of supports and 3 stems. Okay, but we do not want to export with the supports just now. And we dive into this network here. And just to show you, this is another network that is based inside this network. And what it does, look at these 2 nodes here and pay attention to the parameters. It gets the geometry from render geo, which is this node. And we're currently looking at that. So it grabs that geometry, and then this wedge node has all the 16/8 keys from the ApoMaker layout, and it controls this parameter. So if we dirty this, we get 68 work items, and these dots correspond to these entries. So here's a plus sign. Oops, sorry. Lost the click. Here's the plus sign, corresponds to this. So, and 3 is 0, and so on, and so on, and so on. So what happens now is we get the geometry, we iterate through all of these parameters, and then we save them out to disk. And as you can see, as I click here, this parameter is overwritten. That's what this export does. The target parameter is the new parameter 4, and it corresponds to these values. So if we dirty and cook this node, Houdini is going to, should launch 12 separate threads of Python, which is Houdini's Python version. And it's going to generate 68 OBJ files in about a minute or two, depending on what's left of CPU power during the screen recording. But it shouldn't take all too long, and the first files, yep, they should appear. And let's verify them with the preview. This is the 7 key, which is fine. Just another control. Yep, that's the 1 key. And they do get the colors. Let's wait for the next batch, and we'll see more than just a pale magenta any second now. Takes around 500 megabytes per instance. And you can see here, it has already worked on these items. They're darker, and the lighter ones, the lit up ones, they are working their way through all of these. And let's see the escape key. Oh, sorry. Page up. Oh, they're on the right row. Okay, so we're already halfway done, almost halfway done. So you can see this is a really quick process, and yeah, 30 OBJs have already been written out to disk, and now even 40, and this is going really fast. All right, I think this is all I want to show you today. Thank you for your time and your attention. I hope you found this interesting, and I'll hope to see you soon. Have a great day. Bye.